Okay, I just wanted to say one or two more things about this interesting function. Number one, we will see it again when we look at the end behavior, which is when we go out to the left and right forever. Notice this kind of looks like a spring that if you kind of go out to the left, you're kind of pulling it. Like it might be anchored somewhere, maybe at 1, 0. And you're pulling it. Yeah, it's kind of like a slinky. We should have done some slinky day a couple days ago. And you're pulling it out this way. It's stretching. But then from one end, you're kind of compressing it, and so the coils are getting tighter. But as these two things are coming in from both sides, they're oscillating back and forth on either side between -1 and 1. Can we put like an open circle anywhere in there to make it like a hole? I mean, just imagine two things side by side. They're bouncing back and forth, kind of unpredictably between -1 and 1. You can't put an open circle anywhere like at 0, -1, 0, 0, or 0, 1, because that would make it a hole. This is not a jump discontinuity because it's never reaching a point where it's stopping. It's continuing to oscillate back and forth. So it's not a jump discontinuity. It's definitely not an infinite discontinuity because it's staying between -1 and 1. So this is just an oscillating discontinuity. And it is still oscillating. While you are at lunch not thinking about it, it was continuing to oscillate faster and faster. So kind of neat, kind of neat. It'll be even neater when we look at the end behavior in a couple of days. Not a couple of days. A couple of class days. Yeah. Okay, any questions or comments on that one? What are the 3 discontinuities y'all need to be familiar with? Holes, also called what? Removable point discontinuity. Yeah. What was another one? Non-removable jump discontinuity. And then the one we just learned today? Non-removable infinite discontinuity. And then this one's just like if you see it in HEB, you're like, hey, I remember you. So you don't have to know them. Okay? So here you go. Hopefully you're getting comfortable with the idea of the limit and kind of the different information that it brings other than the function value. We have a graph here. When you're talking about the limit at x equals c, it's like drawing a red vertical strip at x equals c. And you are not permitted to even look what's going on underneath there. Hi, thank you. So if you look at this graph right here, the limits are the roads that are leading in. Can you determine anything about the graph right there at x equals c? No, you can't. It could be that underneath that red strip, there's an open circle connecting these. It looks like the limit exists. That's about all you could tell, right? It looks like the roads are kind of going towards each other. But it doesn't give you the complete picture. Similarly, the function value, what you were familiar with coming in, is like having shutters to the left and right of that value, and all you do is you get the information at that single point. So it looks like the function is defined there. It looks like the limit exists, but it's only when you kind of see the whole picture that you can kind of tell then what the true story is of that function in the neighborhood of x equals c. Okay? So the limits of the roads, function value is the what? The bridge, right, if you're going to do that analogy. The roads and the bridge, okay? Here's what I want you to do just to kind of see if you got it. There is a graph here. It's a piecewise function. We don't have the equation. It would be kind of an ugly equation because it's an ugly graph. In Latin, we call this graphus interruptus. And what I want you to do is just take maybe 2 minutes and go through A through L entirely on your own. And I'll do it on my own, and we'll see if I did well, okay? What's A? The limit as x goes to -2. You're going to use my computer. If you're watching this video at home, you don't have to pause it. You can just let it play while you do this. you're welcome. Let's see how you did. If you start off, it looks like infinity. My cell reception, my reception is gone. There we go. You got infinity for letter A, and it looks like you got 4 5s in a row. Any questions on any of those, A through D or A through E? And then you got infinity, 4 3 2 3 2, and then the last one that's not showing is also a 2. Also a 2. Do we need to look at any of those more specifically? No? Someone asked last period around what was happening at 8. The limit as x goes to 8. Which one was that? That was number J, or letter J. The function value is up here at 5. That's where the dot is. But the limit on both sides is approaching the open circle, which is at 4. Something else that's kind of interesting about this function is you notice that here at -2, there's a vertical asymptote. So the general limit at -2 is infinity. It's going up to infinity on both sides. But what is f of -2? Yeah, in this case, it is explicitly defined to be a 2, which can definitely happen. You could take the volcano graph, 1 over x squared, and let it be that graph anywhere except 0, and then define it to be anything you want at x equals 0. So most of the time when we have a single function that's defined by a single piece, if there's a vertical asymptote, there is no function value at the vertical asymptote. It has to come explicitly through a different piece that defines it explicitly at that point. So if you got all of those right, then I think you probably understand this section pretty well. You will have questions sometimes that deal seriously with just a graph, and you're trying to answer questions just like that. So anyway, that's it for 1.1. The technology is shutting down, so I think that's probably a sign that I need to give you the rest of the period to finish your worksheet, which is a very rare thing. Normally we would roll right into 1.2, but it's been a long, short week, and I'll let you have the rest of the time to complete the worksheet. The worksheet's due on Tuesday, because we're off Monday, and we'll also have a quiz over anything from 1.1 on Tuesday, okay?